Okay, we're back for 4-2. So we've been talking about rational functions. The first one was about specific inverse variation, right? But kind of like I said in the beginning of that video, a rational function is really any function that includes division. So in this case, it's one function being divided by another, p of x over q of x. Okay, and so today we're going to be graphing. How can we get a general sketch or a graph building on our knowledge of key features of functions? So one thing to note is that if you have a rational expression, the denominator cannot be 0, right? Because then it's not defined. So here it simply says q of x cannot equal 0. And the same thing is that the domain can't include anything that makes a denominator 0. So if I plug in a 2 and it makes a denominator 0, x cannot be 2, right? Because we cannot have a 0 in the denominator. So that's going to help us figure out where our asymptotes are of these functions. Because if you remember, we were looking at reciprocal or inverse functions in the last video, and they look something like this. This is a general form of rational functions. There are asymptotes and curves, and the curves can't cross certain places, right? So here's a note about asymptotes, right? This is something you're going to want to write down in your notebook. So let's just say you have these two functions being divided by each other. A times x to some power m divided by another function that's to some power n, right? So since the denominator cannot be 0, can't equal 0, the vertical asymptotes can be found by setting the denominator equal to 0 and solving for x, right? So if I plug in an x down there of some value and it makes it 0, it cannot be that number, which means it's a vertical asymptote. So if you ever need to find the vertical asymptotes, you set the denominator equal to 0 and solve. What about horizontal asymptotes? So for horizontal asymptotes, you have to look at the powers on the two functions in the numerator and denominator. So the numerator has a power of m, the highest power. You're looking at the highest power only. And then the highest power of the denominator is n in this example. So if you look at the powers m and n, if they are equal, then you can find the horizontal asymptote by making a ratio of the coefficients. Oh, it's a typo there. Supposed to be with the coefficients, so it should be a over b, right? So the horizontal asymptote here would just be whatever a is over what b is. If the highest power in the numerator is greater than the highest power in the denominator, there's an asymptote at y equals 0. And if it's the other way, right, if m is less than n, there's no horizontal asymptote, but there may be a slant asymptote, which we're not going to get into now. Maybe later, coming. So right now you only need to worry about the horizontal asymptotes. And the reason why this all works has to do with long division. If I take this function and perform polynomial long division by this function, you end up with a remainder, and that remainder tells you where the asymptotes are. It's actually that remainder, if you get one, will tell you the equation of the line for the slant asymptote. But we're not going to do that now. So there's proofs with all that. And you can actually perform the long division to find the asymptote, but in the end you discover that these three rules exist, so why do all that, right? Okay, so let's continue on. Let's try graphing some of these. Okay, so here we have g of x equals 4x over x minus 3. All right, so I'm just going to, let's see, I'm going to make let's just set up my graph so I can start drawing it as I get some information. This is that thing where we're just going to start pulling out some key information. Okay, so the first thing I can start finding are x and y, are vertical and horizontal asymptotes, right? So for my vertical asymptote, I know I can set the denominator equal to 0. So when x equals 3, I get a value of 0, so I know x cannot equal 3. So there's a vertical asymptote at x equals 3. So I'm going to actually come in and draw that. Okay, and I'm just going to make my asymptote a light color so you can still see behind it. Okay, there's my horizontal asymptote. It's a little crooked, but you get the idea. All right, let's talk about, vertical asymptote. I'm saying the wrong thing. Now let's talk about the horizontal asymptote. So this is where I look at my powers. My power in the numerator is equal to my power in the denominator. They're both 1. So my horizontal asymptote is going to be equal to the coefficients of those two. So 4 over 1, which means it's at 4. So I can come over here and at y equals 4, 1, 2, 3, 4, I also have this asymptote. So now I'm just trying to figure out where the graph is being drawn, right? It's either going to be here, 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 or here. So how can I do that? Well, I know no matter what, it's going to cross the y-axis either up here or down here. So I can find where it does that, right? So let's find the y-intercept. This is going to be when x equals 0, right? So let's plug in 0. Y equals 4 times 0 over 0 minus 3. That's equal to 0 over negative 3, which is equal to 0. Okay, so I have 1 point. See, I'll draw my graph in blue. I know it crosses right here. Okay, is there going to be an x-intercept? So that's going to be when y equals 0. So is it possible to have this? Right, I can cross multiply and solve. 0 times x minus 3 is 0, so 0 equals 4x. So 0 equals x. Oh, we already have that. So there's no additional points. Okay, great. So now we just start making our table of values. And what you're going to do is start picking points in these quadrants, right? So I know what's happening at 0, so maybe I'm going to test minus 1. And then maybe I'll come over here and see, really I could just get 1 and get the sketch, but let's try also positive 1. And then let's try a couple on the right side of this asymptote. So we could try 4 and we could try 5. Okay, so what happens if I plug in negative 1? If I plug in negative 1, I end up with 4 times negative 1 is negative 4 over negative 1 minus 3 is 4, so that's minus 1. Oh, sorry, 4 times negative 1 is negative 4, and negative 1 minus, yeah, this is positive 1, right? Let's check in my signs. So I know I can come over here and actually I'm just going to solve all these and I'll come draw them. All right, what happens if I plug in 1? We'll end up with positive 4 over 1 minus 3 is minus 2, and 4 divided by negative 2 is negative 2. All right, what if I plug in 4? I end up with 4 times 4 is 16 on the top, and 4 minus 3 is 1, so that's 16. And then 5 times 4 is 20, and 5 minus 3 on the bottom, we get 2, which is 10. Okay, so now I come over and plot these. Negative 1 is positive 1. 1 is minus 2. 4 is 16. 1, 2, 3. So it's like really high up here. I'm going to put that up here. 4, 16. And then 5 is at 10. 5, something like that. Okay, so now when I connect these, I can see that my function is actually going to live down here, and it's going to live up here, and it's never going to touch this, and nor is it ever going to touch this vertical asymptote if I continued it up. Right? So there's my sketch of this function. Okay, we're going to do a couple more of these together. All right, actually this one first is find all the asymptotes of this function. So that's just testing what you remember about the rules for vertical and horizontal asymptotes. So remember, vertical asymptote means I can set the denominator equal to 0, right? And now I'm noticing that I can factor this. Hopefully you see it's x plus 3 and x plus 4, right? That's how I can get that 7 in the middle. So what am I finding out? I'm finding that x cannot equal negative 3 and x cannot equal negative 4, right? Those are my vertical asymptotes. What about my horizontal asymptotes? Well, I need to look at the powers. Here I have an x to the first power over an x squared. So if I look back at my rules, m is less than n, right? So there's no horizontal asymptote in this one. There may be a slant asymptote, but we don't need to figure that out. Horizontal asymptote, none. Okay, let's keep going. Let's do another graph of a sketch of a graph. This time it's of 2x plus 1 over 3x minus 4. So before I even graph, let's start with vertical asymptote. Let's set the denominator equal to 0, right? These are going to be kind of your steps here. Get 3x equals 4, so x equals 4 over 3. Right, that's my vertical asymptote. Horizontal asymptote. Look at the powers. My powers are the same, so my horizontal asymptote can be found by looking at the coefficients, 2 over 3. All right, and then sometimes sketching, let me do this, drawing the graph here lets me start to figure out, are there going to be x or y intercepts, right? If I look at the asymptotes. So I'm just going to go out by 3 and hope that works out. Okay, so I'm noticing I can do a horizontal asymptote at y equals 2/3. So something like that. And then I can write it here just so I remember. And then x equals 4/3. It's a little bit bigger than 1. Okay, there's my asymptotes. So yeah, there's going to be definitely a y-intercept, but there may not be an x-intercept, right? Because it may be up here. So let's find out where the y-intercept is, and that'll help us figure out if there's going to be an x-intercept. So for the y-intercept, that means x has to be equal to 0. So I'm going to get y equals 2 times 0 plus 1 over 3 times 0 minus 4, which comes out to be 1 over minus 4. So there's a y-intercept at y equals negative 1/4. So something like here. So now I know my one of my curves for my rational function is going to be down here. So that means my other one's going to be up here, right? Because they're never, more than likely it's going to be up here. It can be like this. I didn't want to say never. But so we can check. X-intercept is going to be when y equals 0. So let's do that. So then we can cross multiply that 0. So you get 0 equals 2x plus 1. Minus 1 equals 2x. So x equals minus 1/2. So yeah, here's my x-intercept. It's right here. So it's helping us with this side a little bit. We still don't know what's happening on the other side. So this is where we start making our table of values. Okay, so I already kind of know what's going to happen here. It's going to go like this, right? Because those asymptotes are telling us it's never going to pass that. So now I'm just going to pick some points over here. What's happening over here? Let's try 2. And let's try 3. So if I plug in 2 to this function, I'm going to end up with 2 times 2 is 4, and 4 plus 1 is 5 over, I plug in 2, 3 times 2 is 6, 6 minus 4 is 2, so 5/2. What if I plug in 3? 2 times 3 is 6, 6 plus 1 is 7, over, 3 times 3 is 9, 9 minus 4 is 5. So we're in the positive part. So at 2, I'm at 5/2, which is 2.5, something like here. And at 3, I'm at 7/5, so a little bit more than 2, but it's going down, right? So what's happening is this curve is going down, and I totally missed my spots. I think 7/5. Oh, it should be less than 2. I have mine greater than 2. 7/5 should actually be something like that. I was like, why is my curve so weird? So something like that. Right, there's my sketch. There's why you shouldn't do math in pen. And hopefully you have some graph paper so it's a little easier. All right, let's try one more sketch. What if you had to sketch this function? So you should be thinking now, hopefully you're getting in your mind first, let's find asymptotes. I always start with the vertical asymptote because I don't know. Maybe I like factoring more than looking at the powers. So we have to set this equal to 0, right? So I can see that I can factor this to x plus 5 and x minus 3. So my asymptotes are that x cannot be minus 5 and x cannot be 3. And then my horizontal asymptotes, I'm looking at the powers. They're equal. So my horizontal asymptote is going to be at y equals 4 over 1. So other thing I hope you're noticing is there's two ways you can write this, right? This is my work for my vertical asymptote, and so I wrote here that x cannot be these things. Or you can say vertical asymptotes at x equals -5 and x equals 3, kind of like how I did here. So there are two ways to notate that. So I'm just going to come over here and draw my graph. So I can start putting these in. Let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so I have a vertical asymptote at x equals -5 and x equals 3. And then a horizontal asymptote at y equals 4. Okay, so now we just got to figure out what's going on in these other places. So first thing, let's find our y-intercept. So y equals 4 times 0 squared minus 9 over 0 squared plus 2 times 0, 0 minus 15. So I end up with minus 9 over 15, minus 15, which is 9/15. All right, so our y-intercept is at 9/15. That is a little bit more than half. So I'm going to just come in and put it right there. Okay, so now I wonder what happens on these sides. Is it more than likely I think it's going to U down, because then it would run up here. So I'm thinking it's going to look like this. But let's see. Let's try our x-intercepts. So this is when y equals 0. So 0 equals 4x squared minus 9 over, and I'm just going to use this factored form down here. Which doesn't even matter, because when I cross multiply to solve, it goes away. I get 0 equals 4x squared minus 9, which that means 9 equals 4x squared, which means x equals the plus or minus root of 9 over 4, which is plus and minus 3 over 2. So we have an x-intercept at positive 1.5 and negative 1.5. So I can already see what's happening down here in this portion of the graph. It's curving down like I expected. Okay, now we got to figure out what's going on these sides. So let's make our table of values. So we're at 5 here. Let's pick, I don't know, -7 and -6. We have done this part, so then let's come over here. Let's try 4 and 5. Okay, so when I plug in -7, so let's see. I'm going to use this factored form because it helps me. So -7 squared is 49. 49 times 4 is, doing this with my calculator, take away 9. It's 187 over 7, that's -2. And -10. Let's see. This is what I'm just going to plug this in my calculator. End up with, let's see, divided by -2 times I get negative. Now I want to check, because now what I got the first time is different. So let's type this in. I don't know if you guys have this calculator. If you know, you can do this. Where's my table? It's not gonna let me do this. So I'm going to type this in. Because when I did it the first time, I got 15, and now I'm getting... Oh, no, I got 9.35. I ended up with... I think this is positive 20. You end up with 9.35. You guys can check if it's incorrect or not. Negative, when I plugged it, I'm just going to write what I have. When I got -6, I got 15. You guys can try and check and see if it's right. When you plug in 4, you get 6.11. And when you plug in 5, you get 4.55. These don't work out as nicely. Right, but they give us a rough estimate. So when I get to -7 here, I know I'm in 9.35. So this is 1, 2, 3, 4, 5. 9.35 is like up there. And then when I get to -6, this is why. Yeah, -6 is 15, so it's even higher. There's this other blue. So this is what's happening is something like this, except it's never touching that, right? It's never touching this asymptote here, so it straightens out. Then what's happening on this side? Well, I'm at 4. I'm at 6.11, so I'm definitely above this, and then it gets down to 4.55. So this side is like that. And you can always graph it in Desmos and see, but let's see how wonky my sketch is here. 4x squared minus 9 divided by x squared plus 2 x minus 15. So yeah, it's something like that. And that's, I was thinking mine was wonky because this one was a little bit lower than that one, but it actually is kind of how it looks. It's also not a perfectly symmetrical downward shaping U here, which I may have been able to find by finding some more points in between. But it's a rough sketch, right? It gives me a general idea of what it looks like. All right, I'll see you guys next time.